Sir, I'm saying yes, it is done.
Yeah, it is done. Then what is next?
Sir, next is wait. Yes. Next is how to find the the center of mass of an irregular shaped object.
Irregular shaped object. That is lamina, right?
Yes.
Lamina. Yeah, here. We gave you three steps, right?
Yes,
In
sir.
your copy, it's not written there. These three steps.
It is written, but even after reading, I
What what
didn't
is
understand.
what is written there? What is written there? Can you please tell me?
Sir, you told to draw the diagrams, right?
Mm-hmm.
You have to first mark the three diagrams, then from there we have to um, is the pin. That is that is what is written in my copy.
Diagram and what is written?
You have to point the three diagrams and draw a line through it, and then you have to intersect like that two parts where the lines meet. That is the center of the gravity. That is what is written in my
Okay,
copy.
the diagram is showing us the steps, right? How to get the center of mass. You have a uh, nail here, right, at the top, and this object, irregular shaped object, is placed on this nail by a hole, right? So that it
Yes,
can move freely. Then we are having one thread here. This thread is attached to a this thread is attached to a
plumb line.
yeah, this one is any stone or any mass. Okay, so that this thread is straight. Okay, we simply say it plumb line. So this plumb line is used to get the line. Okay, to get the line to be drawn using a pencil and a scale, right? From this point through this uh, towards the plumb line. Is it clear?
Yes, sir.
Then second step is we will take another hole on the object, irregular shaped object, and we will do the same process. We will draw another line. Okay, is it clear?
Yes, sir.
This
Yes, it
way,
is.
and the third hole we are placing the plumb line and the object. Then we are getting third line where the three lines they are intersecting each other. That point is center of
The center of mass.
mass of the irregular shaped object.
Okay, sir, in the structured part of 3A21, to find out the weight, we have to halve the length, right?
Yeah, half the length.
We have to halve the length because the center of the mass is in the middle.
That is regular shaped object. That's why we can find it easily. That will be in the middle. For regular shaped object, the
Yes,
center of mass should be in the middle always.
yes. In my copy, I wrote the wrong. I didn't have, when finding out the weight, I didn't have 0.70. That is why I was confused. Because
Hmm.
the if the
Hmm.
center of the mass is in the middle.
Hmm.
But if, in writing the moment, I halved it, so that is why I was confused.
Hmm.
Because of weight is then when it is 0.70.
Now you understood, right? That one. So this one is also done, right? Irregular shaped object. Now, which one you have? Pressure, right? Topic 7.
Sir, in topic, yes, I
Sir,
have problems in that topic.
Yeah, Anmol. Say,
Sir, you explained that number three question.
yeah, yeah, explain.
Oh,
That's
sir.
because of center of mass. Okay, center
Oh,
of
okay,
mass
sir.
is in the middle. That's why we are taking the half length. When it is
Okay,
closed, the force is working. That is weight, right? Weight is working in the center. That's it. Got it?
yes.
Yeah, notes. Here is the notes.
The weight will be 0.35 into 10.
Nah, huh? Weight?
Yes, the weight will be 0.35 into
No,
10,
no, no.
right?
The weight will be 20 multiplied by 10 because uh, 2 multiplied, maybe 2 kg, right? I can't.
Yes, sir. 2 multiplied 10, 20
Yeah,
Newton.
yeah, 20 Newton. Weight is 20 Newton,
Yes,
Oh,
and weight is force there. Okay.
20 Newton.
So where you have problem, Lamisa? Pressure? Did you go through everything?
so, yes, can you go down? Yes, more down. Down, down. Not this, not this. This is, this is easy. Yes, a little like the object, the pressure of the object. Then the mercury barometer, yes. This is the things I
Mercury
have problems
barometer,
with.
you have problem?
Yes, sir.
Yes, mercury barometer, like the pressure of mercury barometer, and also the pressure of object in a water, in liquid.
Hmm.
Like the pressure exerted on the object on water, I also have problems in that, and Boyle's law.
Hmm. So
I also have problems in
the
manometer.
mercury barometer, you see, this one is measuring the atmospheric pressure, right? So atmospheric pressure is coming from the liquid, right? The reading is
Yes,
coming from the liquid. Like if the atmospheric pressure is more than the liquid here in the bowl, it will be pressed, right?
Shazan,
Hello?
yes, sir. Shazan, sir, I understand how the atmospheric pressure is taken, but I don't understand the formula for like, you know,
Okay, okay, okay,
the
okay. Then formula
that
we are going to
yes,
see.
that that's that is what
Yeah,
I have
yeah.
problem.
See here,
Yes,
pressure due to mercury column. How we are calculating the pressure, right? Pressure due to mercury column. As the mercury column went up due to atmospheric pressure, so the pressure calculated using the mercury column, that is giving us the atmospheric pressure, right?
yes,
Have you
sir.
got it? That's why we are taking the pressure due to mercury or pressure due to the liquid. So when we are getting the formula pressure due to mercury, that is H rho g, right? We
Yes,
got it,
sir.
right? So H
Yes,
rho g means you have rho is the density of mercury, g is the gravitational field strength, and H is the height. Okay, and height, we know that at the sea level, the height of the mercury is 760 millimeter or 76 meter centimeter. That is coming here 0.760 meter.
sir. One more question. One more question.
Sure.
Here, I did the like maths, and I multiplied it by 10. But if I multiply it by 10, it comes 7.74. And then I noticed it is written gravitational acceleration. In Is it different in Mercury?
Listen, for Mercury, the density is this one, 13.6 into 10 to the power 3. This is showing the density of the mercury, okay?
Yes, sir.
And G is written here 9.8, that is equivalent to 10, right? But they wrote here exactly 9.8. Is it clear?
Yes, yes.
And
But I tried it to and the answer comes different. Why? Then shouldn't it be the correct answer 0.74?
yeah, did you use 10?
Yes, I used 10.
But they use 9.8. That's the reason. Have you got it now?
Okay, sir. But if I also use 10, it will be correct, right?
Yeah, it will be correct. No problem. Actually, this one is not coming in your exam. Uh, Only we are
Okay.
showing this one. I did not. You see your notes. I did not tell you to write everything, did I?
No,
When
sir.
when we did the class, I did not tell you to write everything from the notes, or I did not discuss all the things from the notes. I only gave you the thing, those are directly coming from the learning outcomes, and those are necessary for you, okay? This part is a bit more explanation, okay? That which height is uh, showing us atmospheric pressure, which height of the mercury level is showing us atmospheric pressure. Is it clear? Hello?
Yes, sir.
So
Yes, sir. It is clear.
this one will not come in your exam like this. And the questions which
Okay.
will come in your exams already we did in worksheet, right? We did
Yes,
some
sir.
questions related to liquid pressure, H rho g. We gave you the value of density, we gave you the height, then we calculated the pressure, right? Accordingly, isn't it?
Sir, then, yes.
Then next we have you said about
Manometer. The manometer, yes.
manometer
I
one,
have to
manometer.
use the
Okay,
manometer.
manometer. Manometer, we are going to find the gas pressure, right?
The pressure.
Yeah,
Here
gas
it is the
pressure.
same.
Yeah, gas
Yes.
pressure
As
we are getting. And for getting the gas pressure, we are using liquid pressure idea, isn't it? So here we have two conditions. Sometimes gas pressure is less than atmospheric pressure, and sometimes gas pressure is more than atmospheric pressure. So the diagram you are seeing, what is greater? The atmospheric pressure is greater or the gas pressure is greater?
the gas pressure is greater because in the right
Yeah,
side it
yeah,
is
very good, very
the
good.
liquid.
That one is important to understand that here gas pressure is more. That's why the atmospheric pressure side, the liquid level is going up, right?
Sir,
If
P naught is gas pressure.
P naught is atmospheric pressure, because that one
Atmospheric,
is,
right?
yeah,
Yes.
that one is open side, right? Always the open side is giving you the atmospheric pressure, right? Hello.
Yes, sir. Yes, sir.
So when you are getting the pressure like this, that means your gas pressure will be the sum of atmospheric pressure and the liquid pressure, okay? Have you got it?
Okay. Yes, sir.
And vice versa, if your atmospheric pressure is more, gas pressure is less, that time it will be opposite, right? You have to subtract the liquid pressure from atmospheric pressure to get the gas pressure. Is it clear?
Okay. Yes, sir. It is clear.
Very simple, very simple. We just try to understand from one diagram, then if it comes in any situation, you can answer. Then anything more?
Um, let me see. Yes, Boyle's law.
Sir,
Boyle's
Boyle's
law
Boyle's law.
mentioned
Oh,
that.
Boyle's law. Boyle's law.
yeah.
Boyle's law, actually, we are simply understanding it. The more on Boyle's law you will get in thermal physics. We are already done with topic 8 and 9. Then we have topic 10, temperature, that is related to different kinds of thermometers. And after that, 11 and 12, there will get more details about the Boyle's law. Okay. Now we have little bit here. You see what is Boyle's law? If you have more pressure, then the volume is less, right? Look, you are applying the right side diagram, you have more pressure, that's why the volume is smaller, isn't it?
Yes, sir.
How we understand there is more pressure? Because 1 2 3 4
It's
arrows are
compressive.
given. Okay, 4 arrows are given, that shows more pressure, right?
Yes, sir.
And the left side one, we have 2 arrows only, that shows less pressure. So less pressure, we have greater volume. That shows uh, if we relate with pressure and volume, it's inversely proportional. If pressure is more, volume is less. If pressure is less,
Less
then volume
volume is
is more, inversely proportional, right? So that one we can write this way: P is directly proportional to 1 by V. We can say P is inversely proportional to V. Okay,
yes. Sir,
and yeah, say
why is PV is equal to constant? What is
yeah,
constant?
yeah. This is mathematical rule that like you have a formula V equals d by t, right? You have one formula, that is speed equals distance over time, right?
Yes, sir.
V equals d by t. Okay, now for example, your friend Mithila, you two friends are having a competition in your school. Like you have the ground floor, so from one part to another part of ground floor you will walk. Okay, isn't it?
Um,
You will walk, and we will check who is going fast and who is going slow. Okay, that
oh,
one, that one, the if you are going fast, that means you are taking less time, isn't it?
yes, sir.
And that is showing inversely proportional. That means time is inversely proportional to speed, right?
Yes, sir.
So we can write this uh, for you and Mithila both. You have distance is constant, right?
Yes, sir.
So we can write V is inversely proportional to T, right?
Yes, sir.
This one is the way to do the mathematical formulation. If here D is constant, then we can write B is inversely proportional to T. That means if your time is more, then your speed is less, isn't it? So
Yes, sir.
in this relationship we can write Vt equals constant, right? We can write constant,
Yes,
right?
sir.
So Vt equals constant. That means your distance is same, right, for both of you?
Yes. Oh, now I understand.
Yeah, I know you will understand. Okay, is it
Okay.
clear now?
Sir, that the formula PV.
P1.
Yes,
Now,
it's clear.
you see, like your speed is uh, V1, and the time taken by you is T1. The speed of Mithila is V2. The time taken by Mithila is T2. So if you multiply V1 T1, you will get the same distance. V2 T2, same distance, right? Have you got it?
Yes, sir.
Same thing, huh? V1 T1 equals V2 T2. Okay?
Yes. Here the temperature remains constant. That is why it is P1
Yeah,
P1.
yeah. Temperature remains constant means here distance remains constant. Okay?
Yes.
If distance is not same for both of you, then you cannot relate time and speed, right?
Yes, sir.
Similarly, if your temperature is not fixed, then this formula will not work. Okay, got it?
Yes, sir.
Any
Now
more
I understand.
questions?
No.
Anyone, you have any questions, please? Hello. So, Basha Fahad, Basha Fahad,
Oh, sir, another thing.
yeah, sure.
In topic 4a, according to Newton's third law, if two objects collide together, then object B um, pushes a force. It pushes an it produces a reaction force in the opposite direction. But there is also written that some objects stick together. So why
Yeah,
does
yeah,
not the
yeah. Stick together. Like after colliding, two objects can be separated, or two objects can be stick together, right? So when they are colliding and separated, then their mass is separate, right? Like before, m1, m2. But when they are combining, then their mass is coming together, right? Isn't
yes,
it?
and why is that? Because according to Newton's law they should separate, right?
No, no. Actually, when they are colliding, if they are sticking together, then they are behaving like a single object. Got it? Now they are not
Okay.
no more two objects. They are now a single object. Have you got it?
So some objects stick together and some don't.
Hmm. If stick together, then after sticking together, they are now same object, not separate objects. Now their speed will be also common, right? As they are going
Okay.
together.
Sir, why do they stick together? If it is Newton's law, then they should not, right?
No, it can happen. It can happen sometimes, like they are sticking together. You have two objects. One is sometimes it also happens to our real life. Like though it's if you are taking a big object, right? Like you are taking one big block with heavy mass, and you are taking one small stone or brick. Then stone is going one side and the brick is going other side. But when we have the block is touching the stone does not have that much momentum, right? but the brick it has, so it can now uh, uh, work together with the stone. Okay. Hello.
I didn't understand the brick
Hello.
and stone.
Hello. Have you
Yes, can you
understood?
repeat it for me?
Like
Yes, sir.
I can give you another example. Like you have uh, seen it on the street anytime or not, I don't know, but you can imagine it like a truck or lorry, big lorry is going right with
Yes, sir.
speed and momentum is going, and in front of it there is a small rickshaw or bicycle, right?
Yes, sir.
So
Yes.
that time what happens, if there is any accident, the rickshaw and the truck lorry, they will go together, right? Isn't it? It
Yes,
happens,
sir.
right? So that time it's totally now one object, completely one object. The mass togetherly mass will work together, and the speed is also working together. You got the example?
Yes, sir.
Okay.
Yes,
I
the
did
truck
not,
has.
yeah, I did not want to give this example actually, but you made you pulled me to bring that example. Otherwise, you couldn't understand it properly. Okay, thank you.
I'm sorry.
No, no problem. It's
Actually,
all right. It's all
okay.
right. You understood. That's our greatness, right? Our teamwork. Okay. Okay. So
Yes, sir.
you all get prepared the way Lamisa learned and she went for revision. That is really awesome. So we want from you all the same revision. Okay. Then I hope you can do better, inshallah. Okay.
Yes.
Hello. Best of luck,
Yes,
everyone. Huh?
sir.
Best of luck, everyone.
Allah Hafiz, sir.
If you have no question, then we will close the class now. You
Okay,
have
sir.
anything
Bye
more?
bye, sir.
Allah Hafiz.
No, sir. Allah
Assalamu
Hafiz, sir.
alaikum.
Assalamu alaikum, sir.
Wa alaikum salam.